Hi, I'm going to give a demo of Agent Caesar. This project has two agents. There's Scorecard Review Agent and there's Submission Screening Agent. First, I'll go over Scorecard Review Agent. So this agent, it takes the scorecard dump file from the input data directory and a SonarQube report, for example, Spring Pet Clinic. And you can control these files, these input files in the .env. You see the scorecard dump file. You specify this environment variable, and for the SonarQube report file, you specify here. Now, for the dump file, all you need to do is you just need to go to the scorecard web page and copy the text and paste it into a text file. That's what I did. This scorecard is the basic code with unit testing scorecard. And you can see here are the questions. Question 1 I just there's 12 questions in this scorecard, and the agent's going to parse this dump uh, into uh, into the questions, and then it's going to. Well, I might as well start it. I'll start it, and then it's going to answer each question based on the SonarQube report file that you specified. Okay, let's look at the logs to see what this agent is doing. Now it dynamically generates an agent for each question. You can see it generates a question, an agent for the 12 questions in the scorecard. And this is dynamic at runtime. It's not hard-coded or configured. It just supports any number of questions you have in the scorecard. And then um, it it calls Llama. Like this is a call to Llama. This post to the cloud provider, which is Nebius, hosting Llama, Llama 3, Llama 3.1. It calls Llama to generate the tool calls, because Llama supports tool calling or function calling. It calls Llama to generate the tool calls, and it initializes the 12 agents as tools. And then you see it tries to get a review for each question. Now, the order of getting the questions is not sequential. It's because this is asynchronous. These requests are to Llama are being made concurrently. You can see for the timestamp, they're all being sent at the same time in parallel. And Llama, see, these are the calls to Llama, all these posts to Nebius for the chat completion, because it uses the OpenAI SDK, the client, for accessing the Llama model. And you can also see the questions are answered in depending on how fast they're answered. So here, question 9 was answered first because um, it took Llama the least time to answer it, whereas question 2 here was answered last, but it took the most time for Llama. These are all executed in parallel and independently. And finally, so it generates the JSON report file, which you can see in the output directory. Before there was nothing here. Now there's a Spring Pet Clinic underscore review. So the format of this report is for each question, um, the 12 questions. it provides a review for the question with a rating, confidence level, justification. Let me wrap this. Justification and feedback points, similar to like a real TC reviewer would add comments. These are these feedback points represent the comments. So like submission has several code smells, and it has to back up the feedback point with the issue keys from SonarQube. So you can check out, you copy the issue key and go back to the Sonar report and find which issue this was, like for this Java issue. Okay. Right. So next I'll demo the submission screening agent. This agent, it takes a submission zip file in the input data folder, and it takes a spec. And you specify the actual file you want to use in the .env as well. So you see the scorecard dump file is scorecard dump.txt, and there's an environment variable for the spec, which I document in the README here. The requirements file environment variable. Okay, I'll clear the output here and start this agent, submission screening. Okay, so it's going to take the zip file. Now this this zip file is actually for this spec. This spec is a challenge that completed, I think, a week and a half ago for the top-coded resource API updated for Prisma schema and for updated Swagger to get rid of Informix, Postgres, Dynamo, Elasticsearch, right? And all this complicated, over-engineered architecture that Topcoder used before for the resource API. And for the zip file, which you see, the zip file has been unzipped by the agent here in the input directory. This is actually the repo for this challenge. I just downloaded it because it's a public repo. I downloaded it, and this hasn't been updated in two months, like for the develop branch. So we can expect that the agent will find files that are not related to the spec in this submission. Like this is the scenario where submitter just submits the repo, the base repo with no changes. Trying to fool the top coder reviewers. So let's see if this agent identifies any unrelated files. Okay, so you see, also it skips, this agent skips skips files that are not source, and you can control that in the config here. In the config folder, there's screening skip suffixes. So, for example, that log file, I think it should be here. Yeah, here. See that .log file, because it's in the skip file, it's skipped here. Also skips, the agent also skips binary files. So the agent goes through each file. You see screening file, and it shows you what file is screened and ESLint. Okay, it really goes through each and every file. And when it has a negative screening result, it shows you the file and it's related false. Right? It's not related to the spec. Okay, now see another negative screening result here. this is Docker Compose. So why is it not relevant? It says because this has configuration for services not relevant to the competition, specifically Dynamo and Elasticsearch, right, which are mentioned as dependencies to be removed. Okay, so that's why the agent rated this as not related, right? Related false. Okay, this is going to take a while to run, so I'll just pause the video until it finishes. Let's see, where is it at now? Okay, it's still going through because this is the entire repo that I downloaded. Okay, so the agent finished. The whole screening from start to finish, it took 226 seconds. So it depends on the size of the submission, obviously, and it generates the screening results here in the output data. So let's take a quick look. There's a summary section at the beginning showing the total files which were screened, 105, and the total files which were found to be not related to the spec, 14. So the percentage is this percentage is 13%, right? And average confidence level in the ratings is about 5%. And here it gives you all the details. Let me just wrap this. Okay, so it has a justification. So whenever there's well, a false, negative rating, you can check like default.js. So why was this determined to be not related to the spec? Okay, it's a configuration file for Node.js. That's fine, but contains reference to Elasticsearch, Dynamo, and other technologies. And the requirements mention that it should only have dependency on Postgres and Prisma as the back end, right? Okay, so that's how the two agents work, and I ran these on my Windows machine, VS Code, obviously, but you can also run them in a Docker container. So I provided a Docker file, and I'm running the container now. So from the terminal, you can just run the same thing like in VS Code, Python scorecard reviewer agent. And now let's change the env to instead of using Spring Eklund, let's use platform UI.json. Now this project directory is mounted to the work directory in the container. So because I made that change for the report file, the SonarQube file, when I run the agent here, now it's going to do the review for the questions on the platform UI, right? The platform UI SonarQube report. Okay, now this SonarQube report file is very large actually, because there's tons of issues found by SonarQube in this project, the platform UI, which is the new top coder UI. It's like it's a comprehensive UI for all the different front ends applications. Okay, so as you can see, it also works in Docker container, and you know it's gonna it's also generating the agents dynamically. If I use a different scorecard with a different number of questions, a different number of agents would be generated, but it would still work the same. Like, and then it would asynchronously get get reviews for all the questions in parallel. See, and then Llama 3 host on Nebby is just going to reply as soon as it completes the inference. So it just depends on how long Llama takes to go through the entire um, SonarQube report to answer the specific question. So question 11 was the fastest, but it still had to go through the entire issue report. So it still took like 27 seconds in this case, and rating is 3. Okay, so that's um, that's a wrap for my demo. Thanks.